Section 4.2 is on the agenda for today. We're going to continue with probability. And you should find that today is, once again, not a bad day at all for probability. Maybe a little tougher than 4.1, but should not be an issue at all. Misleading stat before we get into this today. How about this one? A tech firm discovered that 40% of all sick days were taken on a Friday or a Monday. Horror of horrors. What a bunch of slackers, always taking off Friday and Monday. They immediately clamped down on sick leave before they realized their mistake. What was their mistake? There's 5 days in a week. Friday and Monday is 2 out of the 5. That's 40%. It would make sense that 40% of sick days would be on a Friday or Monday. I'm rather shocked it's not higher than that. Okay, so that's a good one. This one is a real, this one is one of my pet peeves, okay? And it's an old one, 7 years old now, but I wanted to talk to you about it because it's, like I said, one of my real pet peeves. Dr. Oz, the famous Dr. Oz with his TV show and whatnot, presented a woman, carried her cell phone in her bra, developed breast cancer in her breast at the very spot, right next to the phone. He cautioned all women to take the phones out of their bras because of the probability of getting cancer. By the way, this is called anecdotal evidence. You didn't do a study. You didn't examine a lot of different people. You took the word of one person, anecdotal evidence, okay? Usually unreliable, usually not something you want to really seriously consider. As a matter of fact, the thing that's really interesting, I remember the show. He said to the woman, he said, "Give me your phone," that supposedly caused the cancer. She handed him the phone and he took it and threw it across the TV auditorium. A bit of showmanship on the part of Dr. Oz. Anyway, compare this anecdotal evidence with a massive 18-year-old study published in the October 20th, 2013 issue of British Medical Journal. They compared cancer rates in 360,000 cell phone users with rates among adults who don't have cell phones. 360,000. What they find? No significant higher probability of cancer between users and non-users, okay? And I'm not even saying that was run as a designed experiment. They just examined information from 360,000 people, okay? But even that showed no difference in cancer rates. Okay, so now in 4.2, we talked a little bit our last time together, your total sample space, like when you throw 2 die. Your total sample space is the 36 possibilities that can come up, okay? The event is what you want that goes on the top of the fraction, and the 36 possibilities for throwing 2 die would go on the bottom. Like if I said, what's the probability of getting a 7? 7 we found out is the most likely to get when you throw 2 die. You can have a 1 and a 6, a 6 and a 1, a 2 and a 5, a 5 and a 2, a 3 and a 4, or a 4 and a 3. Total of 6. So there's 6 in the event to get a 7 out of 36, okay? Which divide that out, I think is right around 17% chance, all right? So you can do this events very nicely when you use Venn diagrams. Venn diagrams are when you have a box, like the first one. Here is set E. E does not occur. That is a squiggle, okay? Squiggle in front of the E. If E does not occur, we are interested in this part out here, okay? How about, and we talked about this, oh my. I'm not sure that it was our last time together. It might have been a bit before that. Suppose you have set A, set B. We want A and B at the same time. Remember we talked about telling your parents something. If If you say, I'm going to work on my statistics this weekend and go to the movie, the only way you can be telling the truth is if you do both of them, okay? So where are we telling the truth for both of them? There would be A and B. That's in both A and B at the same time. A or B could be A, so I'll shade A. Could be B, so I'll shade B. A or B, you just throw the two together. Now remember what I told you. Usually in the English language, when we're talking about I'm going to do this or I'm going to do this, we usually think that you only do one of them. But in mathematics, you can do A, you can do B, or you can do both of them, okay? So or means one or the other or both. These are called Venn diagrams. You should be comfortable drawing and shading Venn diagrams, okay? Let's do a bit more probability. We talked the last time we were together about standard deck of 52 cards. A is the probability of getting a king of hearts, B is selecting a king, C is selecting a heart, D is selecting a face card, okay? Find the probability of not D, not getting a face card. Okay, if you recall, there are 3 face cards per suit, Jack, King, Queen. So in all 4 suits, there would be 12 face cards. So not getting a face card, you don't want any of the 12, you would want any of the remaining 40 cards. So not getting a face card would be 40 out of 52. And we were to divide that, 40 divided by 52, and the chances of that happening is 77%. How about B and C at the same time? You got to be telling the truth for both of them, B and C. If I want a king and at the same time a heart, there's only one way you can do that. Get a king of hearts, right? And isn't that 1 out of 52, which is about a 2% chance, okay? What about B or C? Getting a king or getting a heart. Now you got to be careful here with or problems. Getting a king, there are 4 kings, right? So we have 52, we have 4 kings. So it could be getting a king or it could be getting a heart. How many hearts are there? Aren't there 13? But hold on. Hold on. Didn't we already count the king of hearts here when we said 4? Are you with me? Okay. So the probability of getting a king or a heart would be 4 kings, 13 hearts, but you got to subtract 1 because you counted the king of hearts twice. Okay. 4 plus 13, 17 minus 1 is 16 divided by 52. And I get about 31%. Last one, probability of getting C and D at the same time, getting a heart and a face card. The only way you can do that at the same time is get one of the face cards that are hearts, yeah? And are there not 3 face cards in the hearts? All right, so 3 divided by 52, and I get about 6% chance, okay? This stuff is so much fun. All right, now we're gonna have to go in the book on page 146, example 4.2. So get that up so you can follow with me. There's a chart down at the bottom of page 146, okay? And here are the events. We're going to let A be earning less than 25,000, B earning 50,000 or more, C earning between 35 and 99,999, and D 15,000 or more. Okay? All right, so looking at the chart, we want the following events, not the probability, the events, not D. If you are not earning 15,000 or more, you should agree with me, you would be under 15,000. Yeah? If you're not earning 15,000 or more, under 15,000, would you agree there's 69.45 in that event? Following here, everybody looking, page 146, bottom of the page. A and D at the same time. Be careful here. Less than 25 and at the same time 15 or more. Less than 25 and at the same time 15 or more. Remember these? Less than 25 and at the same time 15 or more. Where does it happen both times? Telling the truth? Is it not in between? 15 and 25 is 77.65. Are you with me? Okay, what about A or D? Now this gets a little trickier. Less than 25 is A. D is 15 or more. Well, if it could be less than 25, or it could be 15 or more, could be one, could be the other, could be the whole blooming thing, right? How many people involved? 77 or 18. How about B or C? B is 50 or more, okay? C is between 35,000 and 100,000, give or take $1 there, okay? So if you could do 50 or more, or between 35 and 99.99, there's overlap. Here is 35,000, here's 50, way up here is the 99,999, okay? Okay, so could be B, 50 or more, solid up. C, between 35 and this one. If you do this one or this one, you just lump them all together. Is it not from 35 and up, right? Goes the whole way from 35 or up. So you would want to add 11,301, 15,754, 10,471, 16,886. Got to add those four from 35 and up. Okay? All right. All right, let's talk about mutually exclusive events. Mutually exclusive have no common outcomes. Mutually exclusive. For instance, if you have, here's A, here's B, okay? And what if I say, not A, and A and B. Let's look at that. Not A is everything outside of A. Would you agree? Not A. Look at A and B at the same time. A and B at the same time is this little tiny region in here. I'm going to shade it really dark. There is no overlap between those two. Not A was all lightly shaded. A and B at the same time is the darker. These two events are mutually exclusive. There's nothing in common between the two. Everybody with me? Follow that? All right. Let's do a number line problem. How about X is less than 3 and at the same time X is greater than 4? Here's 3, here's 4, less than 3 is this, greater than 4 is this. There's nothing in common. They are mutually exclusive. So now we want to go to page 156. Page 156, and we want to look at that chart down at the bottom of the page. The tan colored chart at the bottom of the page. All right. Okay, so we've got some problems to do. Looking at the tan colored chart down at the bottom, and look at the events off to the right-hand side. The first one we want to do is A and D at the same time. A is under 21. Under 21, okay? D is over 18. So how many people are under age 21 and more than 18? We got to do both of them. It's an and. So under 21, there's 1197. You'd add those up. More than 18, over 18 is just the 9 and the 7. Okay? So how many events are there in A and D at the same time? It would just be the 9 and the 7 for 16. Okay? How about part 2? B and D at the same time. B is over 30. There's 1 and 1 way down at the bottom, over 30. And at the same time, D is over 18. There's a whole bunch of them. Okay, so B and D at the same time would be over 30, the last two ones, and over 18. It's still just the last two ones. What are in both at the same time? Two people, the 35 and age 36. Okay, how about B and C? Number 3, B, over 30, just the 1 and the 1. C, in the 20s. Whoa. So if it's an and problem, is there anything there that satisfies both of them at the same time, over 30 and in the 20s? No way. B and C, there's no answer to the problem. B and C are mutually exclusive. There's no overlap. Okay? Aren't these fun? How about A and B? A, under 21. B, over 30. There we are again. Under 21 is the 1197. Over 30 is the 1 and the 1 way down at the bottom. There's no overlap there whatsoever. These are mutually exclusive, A and B. Okay? Now this one's going to be a little tricky, so see if you can stick with me. What's an A or B at the same time? Under 21 and over 30. I'm just going to draw it. Here's 21. Under 21 is here. Over 30 is there. Okay? So take that answer. It's an or problem. Under 21 or over 30. Could be this one, or could be this one, or could be both. And at the same time, in the 20s. In the 20s. The only one that's going to be in the 20s is 20 or 21, which is, well, we're under 21, so we don't include 21. The only one at all that is in their 20s and also under 21 is 20, age 20, and there are 7 people that are age 20, okay? Oh, yes, oh. Nothing like statistics. Okay, let's talk about this one. Committee of 12 people is selected from 10 men and 8 women. Okay, so we have 10 men. We have 1, 2, 3, 5, 6, 7, 8, 9, and 10 men. Okay, we have 8 women. We have, I'm not sure how I want to do this. Hang on a second. Okay, let me start again, sorry. Now, so we have 10 men and 8 women. All right, 10 men and 8 women. Okay, let A be at least half of the committee are men. Okay, at least half the committee are men. And B, at least half of the 8 women are on the committee. Question A, determine the total sample space. If you want to get 12 people on a committee out of 10 men and 8 women, you could have 10 men and 2 women, 9 men and 3. You see what I'm doing? 8, 4, 7 and 5, 6 and 6, 4 and 8. Can you do 3 and 9? That's 12, but you need 9 women and you don't have 9 women. Okay, so here's our total sample space right there. Okay, now let's talk about A is at least half of the committee is men. At least half is men. How did I miss 5? Sorry, 10, 9, 8, 7, 6, 5, and 7. I missed that one. Okay. Find A is at least half the committee are men. Well, here at least half is, at least half is, at least half the committee is men here, here, and here. Okay, so here, this is event A. At least half the committee is men. B is at least half of the 8 women are on the committee. At least half would have to be 4 women, 5, 6, 7, or 8. So there is event B. Okay? Now, let's find, list all outcomes. Okay, for what about, could be event A, could be event B, could be one, could be the other, could be both. It's the whole thing. 10 and 2, 9 and 3, 8 and 4, 7 and 5, 6 and 6, 5 and 7, 4 and 8. Yep. How about A and B at the same time? What's in A and B at the same time? 8 and 4, 5 and 7, 6 and 6. That's it, right? How about A and not B? A and not B. Okay. As set A, and at the same time, not B, would be these 2 up here. Okay, so what's in set A and not B? Just those 2, 10 men and 2 women, okay? And 9 and 3. All right, so far? Are A and B mutually exclusive? No, they have overlap right here. What about A and not B? A and not B? No way. They still have overlap up there. How about not A and not B? Not A are these 2 down here. Not B are these 2 up here. They are mutually exclusive, right? Cannot overlap. What is this? Guy going to the dry cleaners. Having trouble getting in the door. I can't help noticing that even though you have 2 doors, only one is ever unlocked. Yeah, it's easier just unlocking one every day. But don't a lot of your customers try to open the locked one? Don't they get frustrated? Yeah, I sit in here and watch them do it a bunch. You'd be surprised how often it happens. Not really, let me guess. About half the time? Whoa, how'd you know? Statistics at the dry cleaners. Ah, yes. You find statistics everywhere. Homework, okay? Some book problems are here. Okay, notice that you're just sketching a Venn diagram for this problem. And then I came up with some other interesting problems for you. All right? This is a tough unit, chapters 3 and 4. Okay? Good luck.